reflection of consumption.
Question for Ladislau.
Architecture. Kenji.
How do you determine boundaries around these narratives?
Didn't give any.
Like what's the cutoff point? What is or is not a narrative? And then kind of follow up to that. In your weighted reverse shadow, where do the weights come from for basically from time zero? Or is there that steering process at the beginning for a certain period?
Okay, so boundaries. What is a narrative? Everything is a narrative. There is no other representation. Separate sheet, a boundary. There are these things called scenes. A certain narrative can be multiple scenes, but they can overlap each other. It's like if you model completely the fact that you have Robbie watching TV, and on the TV somebody is telling a story, then you have like three narratives embedded into each other. Right, Robbie drinking Coke, the guy telling a story, somebody else doing something in that story. So this can happen all throughout. There is no fixed boundary between it. And the reverse shadow is the inverse of the shadow. So it's, let's say, Achilles and Hector are both of them shadowed by King Arthur, and King Arthur is, so you just take the number and reverse it, right? It's the inverse relationship.
My question is about the multi-agent adaptive theory of mind. So I was wondering if you, say for instance, had two different instances of sigma, and where the agents, say for instance, or the agent or whatever you think about, in one sigma environment, has potentially needs to get a sort of a theory of mind of the agents or the agents in the other instance of sigma, and you know, how you would deal with, say for instance, them learning that and the belief propagation. You know, I'm not quite, I don't have a clear enough idea about the architecture of sigma in terms of how you might deal with that, or if you've thought about that.
So I think there are a couple of ways to do that, and I think Paul might be able to elaborate on it. But what we're doing in the current experiments is that we have two agents that are in the same graph, and they're free to operate independently. They have their own reward, their own beliefs, and they get their own perceptions from the external environment. But I believe it would also be possible to have two separate sigma instances that are completely separate and also operating in the same environment and propagate. They would be completely independent even at the code level as well.
But conceptually, it shouldn't be any different. The way we implemented multi-agents here was to actually have an argument in the predicates for the agent. And that was so we could get maximum sharing when they do have something in common, that they would be shared within the functions. But functionally, that's just yielding two distinct sigma agents that can have their own knowledge, make decisions the way they want. So there's really no functional difference at that level in terms of behavior.
In the autobiographies, in this very simple language, how do you distinguish between witnessing Achilles and Hector fighting live, or seeing them on television, or seeing Brad Pitt and Eric Bana fighting in the movie? Because it seems these sentences are very simple and they appear to be not connected to context.
No, well, not in these examples, but if you look at some of the technical reports and stuff I have on the website, so this kind of stuff of representing, so, okay, Robbie is watching television, Robbie is one story, he's watching the movie Troy, that happens to be one scene, that scene is actually two scenes. One is the scene in which Hector is, Achilles is killing Hector, but in reality there is another scene there in which Brad Pitt is an actor who happens to be playing the movie with the other guy, I don't remember who was Hector, and then these two guys are in an identity relationship, so then the way in which that sentence, which I was saying, the quote sentence is, would represent something that Robbie watches Achilles, and then now if at some moment Achilles is saying that some time ago my mother Thetis had predicted that if I go and I'm going to fight at Troy, I'm going to die, but I'm going to have glory forever. So this is both several quotes like this. On the other hand, if I go home, I'm going to have a long life. So all these things can be represented, and they will be several narratives, in several scenes happening simultaneously, connecting with identity relations. Some of these instances might not exist because we know that Hector actually dies at Troy, but there is also a story about Hector who doesn't fight at Troy but goes home and going to have a long, happy life. And so this is okay. Well, so this is representable in the language. Now, whether you take strategy version 1.0420 can actually reason through a set of 7 or 8 scenes in a meaningful way. If you restrict it to one scene, yes. But not across all these scenes. I guess it won't work.
So. I'll ask a question concerning narrative prediction. So the question is, what place in intelligence do you think this kind of prediction takes? Because, for example, you cannot play chess using narrative prediction, and in real life there are a lot of situations similar to playing chess that where you should model and make some decisions based on enumeration of possibilities and so on.
I never thought about doing chess because I think modeling chess is in a later stage. But may I give you a scenario? I think that the way in which people learn chess is by playing, and then you remember certain chess situations before, and then I think most humans, the way they learn is by taking the situations which they had seen before and align them together with their current, and then make a prediction that if I'm going to do one direction or other direction.
So you will still need some generalization of situations, and there is a trade of heights, I think. Don't you think so?
If I may interject, I think one consideration here is that yes, people should learn that way, but they can also play chess after never having played and just been explained the rules, and they can kind of see some things, and they won't play very well, but they will be able to play to a certain degree.
Yeah, but when they explained the rules, that was also a narrative, right?
Yeah.
Yes, true.
So, okay, so, I don't know, okay.
So, I have the idea of inverse reinforcement learning plus reinforcement learning for multi-agents, and I was wondering if you would consider this as a potential solution to AGI safety.
To what?
To AGI safety. I think something that works for in the real world with many different humans with their all with their different goals and utilities, and if you have something that can take all this into account in some way, then maybe it's a good thing. I'm just wondering, what's your opinion about that?
yes, I think it's a good thing.
And do you see drawbacks, or do you think there's no drawback?
Sorry, there's no
Drawback.
drawback. Oh. So I mean, so clearly that's sort of independent. I mean, so in some sense we're looking at if the agents can do better inverse reinforcement learning and understand all the different people they're operating with, then they can make better decisions about how to interact with those people. And whether, I think the drawback would be whether you think it's good that agents can make really good decisions or not.
So is Sigma going to produce the Terminator?
Right, exactly, so that's the question.
And don't you worry that this would lead to some, I would say, over usage of the system, like abusing the system? Since basically you can make it do whatever you want.
Well, I think the question is whether there's more damage to be done by agents that don't understand the people they're working with than they do, right? I mean, I think there are dangers in both ways. And so.
Right. So the way I look at this, I mean, which I think is very consonant with what David is saying, is by adding a theory of mind capability, you make it possible for agents to be much more intelligent in social situations. As with any increasing capability, it can be used for good or bad. And we need the kind of moral sense and things that other folks have been talking about ultimately in there. But being able to behave appropriately in social situations by understanding others, understanding the relationship of their behavior to yours, understanding what they're thinking, and how you should behave as a function of how they're thinking, that's essential to being an intelligent agent in a social environment. So we have to have that for AGI, but then, as with everything else, with power comes responsibility of one sort or another.
So I have one more question on Sigma. So before we can use Sigma to understand people or create the Terminator or anything cool like that, Sigma will need to be able to do some highly scalable reinforcement learning. I guess even deep reinforcement learning. So I'm wondering how you feel the factor graph infrastructure inside Sigma can that scale up to human level, AGI level, deep reinforcement learning, or do you think you'll need to replace it with something broader and more general at the underlying representational level?
Abram, do you want to handle that, or should I?
Well, I think we might have different opinions on this,
All
so
right,
perhaps we should. So I think what Ben is hinting at, I strongly suspect what Ben is hinting at is some stuff that I'm doing to try to broaden the foundations, because I have come to the conclusion that factor graphs will not scale in that way. In particular, they cannot, when we make very large graphs, deep graphs for deep perception or deep reinforcement learning, the computation becomes intractable and the message passing may not do very nice things, other than I believe propagation as an approximation. And that we should be looking at other kinds of probabilistic reasoning that are inherently scalable. Namely, I'm very interested in these sum product networks that have been developed, and in mixed networks which combine aspects of sum product networks with some degree of the less tractable inference. So that's my angle, and that's my kind of wanting to reconfigure the foundations of Sigma to take into account more scalable types of reasoning. But
Right, so I have a bifurcated answer. So first, we have not yet done deep learning in Sigma. We are looking to do that. We've had some initial explorations with multi-level graphs. But this is one of the big directions we're looking at now. I mean, we do have automated perceptual learning, and we have automated, I'd say, transition or action learning, and we can combine those into learning HMMs. We can combine those in learning action models in reinforcement learning. And we're starting to ask, how do we create hierarchies of these in reasonable ways? So can we do multiple levels of speech and language all in the same hierarchy and learn? So I'm going to say I would be surprised if we can't with factor graphs, but we don't know. I understand Abram's argument, and there's a very real argument that if you combine the kind of ideas from factor graphs with some product networks, there are things that are efficient that can't go with factor graphs alone. So there's a possibility. It doesn't mean throwing away sigma, but it might mean going to a deeper and more general representation at the center of sigma. In the same way, sigma is in some sense generalized source memory representation. What Abram's developing maybe yet a further generalization that we put in this context. So both are possible, but even with the limitations Abram describes, I'd be surprised if we can't do it in factor graphs. We're pretty creative in what we can do in factor graphs.
With that, and given the time right now, I think we need to take these fascinating discussions offline and